diagrams are just picture diagrams of electron configurations. So it's taking my electron configuration and putting it in some sort of a picture format, a diagram. So if you see here, we start off with hydrogen, and we know hydrogen's electron configuration is 1s1. How do I make an orbital diagram of that? Well, orbital diagrams usually start with a box or just a line, and the arrow is used to represent my electrons. So I label this as the 1s, and for that one electron, I use an arrow. I first start with an arrow going up. So since I only have one electron, I only have one arrow going up. This box represents the orbital. An orbital is where the electron is found. Remember, in the s orbital, you can only hold up to 2 electrons. So this box can only hold up to 2 electrons, but there is only one to fill in it. Okay? So let's go ahead and write that down, that we use a box or a line, seen here, a little bit easier, okay, to represent our orbital. And arrows represent the electrons. And what we like to say is the electrons are spinning. Now this is very important. The electrons must spin in opposite directions. So whenever there are 2 electrons in one orbital, 2 electrons in one box, or 2 electrons on one line, either way is acceptable, one electron has to spin up and the other one has to spin down, seen by one arrow pointing up and one arrow pointing down. You can never have 2 arrows pointing in the same direction per orbital. Okay, let's look at another example. Here is helium. Here's this electron configuration, 1s2. Since I only have a 1s, then these 2 electrons are going to fill in. I've got one going up and one spinning down. It's as simple as that. Okay? Let's do a few more that involve a little bit more than just the s orbital. Okay? Here's lithium. Lithium's electron configuration, here's lithium, is 1s2, 2s2. So 1s2, 2s2. Okay, now this is going to be the orbital diagram seen over here. Notice I just use lines. In the 1s, there's 2 electrons. One spins up, one spins down. In the 2s, one spins up, one spins down. These 2 electrons are represented by the arrows, and these 2 are represented by the arrows. These are different orbitals on different energy levels. Okay, all right, moving on to another example is boron. Boron's electron configuration is 1s2, 2s2, 2p1. So that's 1s2, 2s2, 2p1. If you notice, I now have the p orbitals in here. And from our previous video, you've learned that the p orbital has 3, or the p sublevel, I should say, has 3 orbitals. Remember, when you open the p room, there's 3 beds, which means 3 orbitals. Each orbital, no matter where it is, whether it's an s, p, d, or f, can hold up to 2 electrons. This can hold up to 2, this can hold up to 2, up to 2, up to 2, up to 2. So let's begin. In the 1s, notice I've labeled them on the bottom, don't forget to label them. I have 2 electrons. One spins up, one spins down. In the second one, I have 2 electrons. One spins up, one spins down. Now, I'm in the p orbital. I always want to start from the beginning. I've got only 1 electron, so it spins up. Always spin up first and start at the beginning. Okay? All right, let's move on to carbon. Carbon's electron configuration is 1s2, 2s2, 2p6. Oh, I take that back. 2p2. Moved ahead of myself. So I've got 2 electrons here. One spins up, one spins down. 2 electrons here. One spins up, one spins down. And 2 electrons here. Now, this is really important, and this is a rule you must follow. Nobody wants to cramp up all in the same orbital. So because I have 2, they each like to take their own orbital before they pair up. Okay? So it's like saying when I open the door for the p sublevel, or the p door, I see 3 beds. These 2 electrons would prefer to have their own beds than to pair up. They only pair up if they need to. But if you notice, there's already open spots, so they each take them singly. Okay? All right, let's look at neon. Neon's electron configuration is 1s2, 2s2, 2p6. Okay, now 1s2, one arrow goes up, one arrow goes down. 2s2, one arrow goes up, one arrow goes down. You can also kind of make your arrows like this. Now 2p6. Watch how they fill. There's 6 of them. Each one goes in separately. 1, 2, 3. They all spin up. Now they must pair, so the other 3 go 4, 5, 6. That is the correct way in which you fill them. That is very important that you make a note about that. Remember, we talked about not just writing what you see, but writing what I also say. Okay? And lastly, let's try magnesium. I've got 1s2, 2s2, 2p6, 3s2. You should be using your periodic table to do that. 1 goes up, 1 goes down, 2 there. 1 goes up, 1 goes down, 2 there. Now I'm in the p orbital. 1, 2, 3, 4, 5, 6. File in separately and then they pair up. And then the 3s, 1 goes up, 1 goes down. So if you remember, S's only have 1 orbital, P's have 3, D's will have 5, and the same thing happens in the D's. They all pair separately, or they all line up separately, and they pair up in the end. Okay, and the F's have 7. Okay, so these rules I was talking about, they actually have names. So the rule that talks about orbitals holding up to 2 electrons and spinning in opposite direction is called the Pauli exclusion rule. And the rule about starting at your lowest energy level and then going from there is called the Aufbau. So what I mean by that is you have to fill the first energy level before you can move on to the second. You can't just jump around to the third energy level. So you have to build your way up. You have to have the innermost energy levels filled before you go on to the next. So you'll never see something like this, you know, energy level 1 only having 1 electron when it can hold up to 2. Okay? That's called the Aufbau. Aufbau means to build things up. That's the end of the video.